All right. So let's take a look. This first section, especially the first part, is pretty easy. It's nothing big deal. It's just like a starter kind of a section. So you're gonna look at this and you're like, oh, Mr. Hamrick, is it gonna be this easy all the time? I want this to be hard. I want to really be challenged, right? And now what you're thinking? No. Somehow I didn't think so. But it is pretty easy. It's not going to be always this easy, but just take some notes anyway. All right. So let's learn a couple words, math words that we've probably learned already before. It's nothing big deal. It's not even like algebra stuff. It's like stuff you learn when you're in elementary school. The first word, oops, forgot to do this. I got to do that, and then I got to do this. There we go. All right. So the first word is difference. Difference could mean a lot of different things, but in the math world, what does difference mean? Subtraction, exactly right. So if something is being subtracted, that's a difference. So for instance, 5 minus 3. What's 5 minus 3? Yeah, told you it's going to be easy, didn't I? All right, but that's a difference. Now, in algebra, you did stuff like this. Like when you were a little kid, you always took a smaller thing away from a bigger thing, didn't you? Because you can visualize that, right? If I had $5 bills, right, and you took 3 away from me, what do I have left? I got 2 left, right? But what if I had $2 and you took away 5 from me? If I only have 2 to begin with, you take 5 away from me, what does that mean? For a little kid, that doesn't mean anything. But you said it. You said negative, right? So it's -3. But what would that mean in like the money world? That means I would owe you $3, right? All right. If I was in debt to you for 5 and I only had 2 and I gave you 2, I'd be in debt $3. So that's kind of like that. So what did I say? 3 minus 5? So let's go 3 minus 5. Okay. Now, but what we did in math classes, especially when you got into pre-algebra and algebra 1, at least the way I taught it, was that we never really subtract stuff. In math, we never subtract. We always add, but a subtraction is actually adding the opposite. Okay, the opposite meaning a negative. All right, so this is how I do this. So when I see a subtraction problem, watch what I do. I turn it into an addition. See what I did? That looks like a weird plus. Let's do that. So I turn it into a plus, but I add the opposite. So what's the opposite of +5? -5. And so what we do is we learn one rule. We don't really learn a rule for subtraction. The only rule for subtraction is turning it into an addition and adding the opposite. That's the rule that we use for for subtraction. But now we've got into an addition problem. What is the rule when you add things together? Well, if they're both positive, you just add them up and you keep the sign, right? What if they're both negative? What do? Like if I had -2 plus -3, you still add them up, right? 2 and 3 is 5, but then you do what with the sign? No. Here, I'll write it down so you can see it. What if I had -2 plus -3? The rule, keep it. That's right. You add them together, so when they're the same sign, okay, you add them together and you keep the sign. So if I add those two numbers together, 2 and 3, what do I get? 5. If I keep the sign, what's the sign on both of them? It's negative, so I just keep it negative. You with me on that? It's coming back to you, right? Sure. So what if I had this 3 plus, I'll do another one. Let's do this one right here. 3 plus -5. Now, they're not the same signs, are they? So we don't just keep the sign, because you can't say keep the sign because I don't know what sign you're talking about. I don't know if you're talking about the positive one or the negative one. So what do? Yeah, when it's an addition and you have different signs, you actually subtract the two numbers from each other and then keep the sign of the, which one? The bigger number, okay? Everybody got that? Yeah. So let's do this. Let's subtract these. What do you get when you subtract them? You get a 2. What's the sign going to be? It's going to be negative. Why? Because 5 is a bigger number than 3. So this is going to be a -2. Do you remember this stuff? Yeah, you did this in Algebra 1, right? Maybe even before Algebra 1. What if you had one like this? What if you had -2 minus, let's do a different, I don't know, I keep doing 5s and 2s, but, so what do you do that? Yeah, exactly right. It's, Abu said -2 plus 5. Because what do you do when you subtract something? You always turn it into addition, but you add the what? the opposite. So let's say this. Let's write this down. Subtract means, oops, sometimes writing on this pad doesn't look too good. Means add the opposite. I'm going to put that in quotes. So that's something that when I taught Algebra 1, I said all the time. Some people say different things. I think this is the simplest, most concise way to say it. I add the opposite. So here's a subtraction problem. That's the subtraction right there. It's -2 minus -5. But I turn a subtraction into what? An addition, but I add the what? The opposite. So I change that from a -5 to a +5. Now I got an addition problem. All right? Remember, the only rules we really learn are addition. Okay? We don't really have a subtraction rule except for adding the opposite. So now look what you have. It's an addition, different signs. So what do? Subtract them and keep the sign of the larger number. Which one is the larger number? 5. It's positive, so my answer is positive. Got it? I know this is pretty easy for a lot of you guys. I mean, some of you guys can just do this in your head, no big deal. But some of you guys need a little bit of practice on it. So that is the difference, okay, right there. That's the first thing that we're going to do. The next word is quotient. What in the world is quotient? What does that mean? In the math world, what is it? I heard somebody say it. Cam? It's division. That's right. So it's division. D-I-V-I-S-I-O-N. Did I spell that right? Okay. Still getting used to writing on this thing. It's been 3 months since I've used this, so my writing's, I don't know, might not get much better by the end of the year. We'll see. So it's division. So let's take a look at this. You can always, just like you can take a subtraction and turn it into an addition problem, you can take a division problem and turn it into a, what do you think? A multiplication problem. So let's do that. Let's just use some, let's just use letters right now, then we'll put some numbers in here. You know what letters are, right? They're just variables. They stand for a number. So you could write this as a multiplication problem. So instead of dividing by something, what we do is this. We multiply by the, anybody want to? No, it's not just A times B. A divided by B is not A times B. It's not the same. It's, nope, there's no C's. We're going to just use A and B. We multiply by the reciprocal or the inverse. Sometimes I say inverse, sometimes I say reciprocal. Do you know what a reciprocal is? What's the reciprocal of 2/3? 3/2. Now, I didn't put equals, did I? Because they're not equal to each other. But that's a reciprocal. So what's the reciprocal of just B? No, just B. Just the letter B. If I just walked up to you in the hallway and say, what's the reciprocal of B? Not just 1. It's, you flip it. So B can be written as B/1, right? What if I flip that? What do I get? 1/B. You see that? What's the reciprocal of 3? 1/3, right? What's the reciprocal of 17? 1/17. You got it? Okay. What's the reciprocal of B? 1/B. Everybody good? Okay. So instead of A divided by B, division is multiplying by the what? What's the word I used? Reciprocal. Okay, so instead of A divided by B, it's A times what? 1/B. You good? So that's what reciprocal is. All right, and that's division. So you can take any division problem and turn it into a multiplication problem. All right? For instance, back in the day when you were a little kid, you did like 2/3 divided by, I don't know, just do something weird, 5/7. Remember that? You never remember? Yeah, fractions. You never had to do fractions? Oh man, we got a long way to go if you didn't do any fractions. But let's do this. That's the division sign, isn't it? Right? Back when you were a kid. But when you started in algebra, they kind of got rid of that, didn't they? They started just doing fractions, okay? But when you're a little kid, you did division sign. By the way, do you know where that division sign, why that symbol is what it is? Because division is basically a fraction. That dot represents the what? The number on top, which is what? What's the math word for that? Numerator. And this dot represents the bottom one, which is the denominator, okay? Anybody ever tell you that? Look at that. That's where the division sign comes from. Isn't that cool? All right, because it's a division, right? Numerator, denominator. Anyway, I always thought that was fun to learn. So how would I do this? Instead of division, we can turn any division problem into a multiplication problem. So you take the first one, you keep it the same, but then we change division to what? Multiplication, and then what do? Multiply by the reciprocal, and you said it. It's 7 over 5. Everybody good? So that's how you do division. If you wanted to, what is that? 14 over 15. So that's how you do division. You could also do that. Before we move on, let's do those same two numbers. 2/3 over 5/7. You could also look at a division like this. When you start getting into algebra, that's when you start seeing stuff like this. We're going to see stuff like this later on, but it's going to be a lot more complicated. It's going to have like a lot of letters. It's going to have like squares, cubes to the fourth, all that kind of stuff, all right? But you're going to need to simplify something like this. Well, it's really not that hard. It's a division problem. What did we just learn about division? We learned that we could always take division and turn it into a multiplication problem, okay? So let's do it. We keep the top the same because the top is the same as the first one, right? So we keep the top the same. Instead of divide, because that's what this bar right here means. It means to divide. So instead of divide, we turn it into multiplication, but then we got to divide, or we got to multiply by the reciprocal. And then we already said this. What's the reciprocal of 5/7? It's 7 over 5. 7/5, or 7 over 5, however you want to say it. You agree that this is exactly the same as this? Yeah, it's just written a little bit differently. But when we're doing algebra, and that's what this class is, it's college algebra, we're going to be looking at stuff more like this than anything. Once in a while, this will pop up, okay, but we'll be doing stuff like this. I mean, we'll be doing stuff like this, like x squared, y to the 5th over x to the negative 3rd, y to the 4th. We're going to do stuff like this, okay? Not today, but eventually we're going to do stuff like that, okay? And we're going to be flipping things and stuff. All right, enough of that. Let's do, don't worry about this. You don't have to write that down. All right, let's do multiplication, but we're going to talk about multiplication by 0. I write my zeros with that little slash in there, because sometimes my z's can look like a 2 sometimes. So I put that little slash. That's a 0. There we go. Yep, that's the next one. Yeah, we can underline it if we want. It's pretty easy. What if I had any number? Call it A. And if I multiply it by 0, what's my answer? It's 0. Any number, real number, I should say. If you multiply it by 0, your answer will always be 0. That's pretty simple. You got it? Yeah. Let's move on. Let's do division. We already did a little bit of division, but we're going to talk about a couple other things about division. The book calls this division properties. Yes, division properties. All right, now, we talked about multiplying by 0. Let's talk about 0 and division. But I'm not going to divide by 0, not just yet. I'm going to put 0 divided by anything. All right, what's 0 divided by any number? A represents any number. It's 0 again, just like multiplication. Okay? Yep. 0 divided by any number. Whether it's negative, it doesn't matter if it's negative, doesn't matter if it's a fraction, doesn't matter. If it's a real number, and we'll talk about the difference between real numbers and non-real numbers some other time. But if it's a real number, 0 divided by that number is always 0. Again, back when you're a kid, do you remember how to check to see if this worked? So for instance, if I had like, let's do this, 12 over 3. What's 12 over 3 equal to? 4. Good. 12 divided by 3 is 4. I don't know if your teachers taught you this, but there's a way to check to see if this actually does equal 4. Does anybody remember? Take this number, multiply it by the denominator, 4 times 3. Does that equal the numerator? Yeah, it does. So it checks. That's one way you can see if it works, right? Let's use that same principle and check. What time did I say quarter after? 15? Is that what it is? Okay. So let's use that same principle and see if this works. So what do? 0 what? Times a, it should equal the numerator. Does 0 times a equal 0? Yeah, absolutely. We just talked about it, right, with this principle right here. So it does work. Do you believe me? Yep. So you can do it on your calculator. Somebody have a calculator out? Put it on the calculator. Put 0 divided by any number. I don't care. Put 0 divided by 5, 0 divided by 100, 0 divided by a million. You'll get a 0. Okay? Now, what about the other way, though? Like right here, a times 0 and 0 times a, is that any different? No, it's no different. All right? It's still 0. But is 0 divided by a the same thing as a divided by 0? I'm going to put a question mark right here. Nana, you got a calculator out? Put a number. Put 5 divided by 0. Tell me what you get. You get an error. It's not because the calculator is broken. It's because you can't do it. All right? It's undefined. You are not allowed to divide by 0. Okay? We won't get into the technical reasons for it and stuff, but no, this is 0 divided by a number. This is a number divided by 0. There's a big difference. Okay? Would you agree that 12 divided by 3 is 4? But what about 3 divided by 12? Is that 4? No, it's 1/4. Okay? So they're not the same, right? If I flip the numerator and denominator, unless, what? The numerator and denominator were the same, right? Then it's just a 1, right? If the numerator and denominator are the same, that's just a 1. So this right here is undefined, is what we say. Okay? It doesn't exist. You good with that? All right. And we just kind of hinted at another property. If you have any number divided by itself, we just said it, so let's write it down. So a divided by a, or any number divided by its same thing, it's got to be the same exact number. What is it? What's any number divided by itself? It's just 1. Okay? Let's do that check again to see if it works. 1 times a is a, and it works. Okay? So we're good with that. Make sense? We talked about adding with negative numbers and positive numbers. Let's do a little bit of multiplication. The title of this little section right here are the rules of signs. Signs meaning what? What 2 signs are we talking about? The 2 signs are we talking about? Yeah, negative and positive, exactly. Okay, negative and positive, those are our signs. Okay, so those are the rules of our signs. So what are the rules when you multiply? Actually, multiply and divide have the same rules. Okay, it's the same exact rules.
If they have different symbols, it's always negative.
Very good. I was going to use A and B on this, but we're a little short on time. I'm just going to put some examples with some regular numbers in here. Okay, so what if you had 2 times negative 3? So, Nisi, is that what you said? You said different ones, right? Yep. So if you have 2 different signs, the 2 is positive, the 3 is negative. If you have different signs, it doesn't matter which one's bigger. Did it matter in addition? Yeah, absolutely. Okay, but not in multiplication and division. Okay, it doesn't matter. As long as they're different signs is always going to be what? Negative. Okay, different signs are always negative. So you just multiply those 2 numbers like you normally would, and you just stick a negative in front of it. So what's my answer here? Negative 6. Okay? What about if you had the same signs? Let's use the same 2 numbers. I'm going to put negative 2 and negative 3 both in parentheses. Everybody understand that, right? If they're in parentheses right next to each other, that means they're being multiplied. I don't have to put a dot. I'm way beyond putting a little X, right? That was back in elementary school. Then they graduated to the little dot, and now in algebra, for the most part, we don't even put a dot for a lot of these, okay? So it's negative 2 times negative 3. Now, this time, they're not different signs. They're the same sign. So what's the rule if, what's the rule if you have the same sign? It's always positive, exactly. So this is just a positive 6. Do we have to put a plus in front of it? No, we don't. Okay, you can. It wouldn't be wrong, but I wouldn't. I just put a 6. The rule for division is exactly the same. Let's use that 12 and 3 like we did before. What if I have this? 12 divided by 3 is just 4, correct? They're different signs. So what's my answer? It's a negative. The rules are exactly the same for the signs. Okay, if they're different signs, your answer is always negative. If they're the same sign, your answer is always what? Positive. Okay? Doesn't matter if the negative is with the 12. Does that make any difference? Not for division or multiplication. It doesn't make any difference, okay? Just with addition, that's the only time where the bigger number makes a difference, okay, what sign it is. But this is still -4. That makes no difference. It's still exactly the same thing, okay? And obviously, if you have, I don't know, we'll go mix it up a little bit, do different numbers. This time you have the same signs. So if you have the same signs, what's your answer always going to be for multiplication and division? It's going to be positive. So what's that? That's going to be 2. All right? And if they're both positive, 8 divided by 4, of course, that's easy. You know that's going to be 2. So just refreshing your mind a little bit with some of these basic ideas. Yeah. All right, let's do another one. This is called cancellation property. You learned about canceling stuff out when you were in Algebra 1, right? Didn't you like that? I always loved canceling stuff out. I don't know, it just felt fulfilling. Just knocking them off, right? Bang, bang. You ever do that? Let's do this. AC equal. Let's go this. 3x equals 15. Let's do that. We can still show the cancellation property with this. Let's say we want to solve for x. Remember doing this? This is basic Algebra 1, pre-algebra kind of stuff. Let's say we want to solve for x. What do we want to get rid of? What's with the x that we want to get rid of? The 3. So what is the 3 doing to the x? What are they doing to each other? They're multiplying because they're right next to each other. So what is the cancellation thing? You do the opposite, right? You do the opposite. So what's the opposite of multiplication? Division. So I just do a little division sign and divide by 3 because that's what I'm trying to get rid of. I'm not trying to get rid of the x. I want the x to stay there. So I'm trying to get rid of the 3. So I do the opposite. Now, in algebra, what's one of our most basic rules in algebra? Whatever you do to one side, you got to do to the other side. Good. So you've been taught this stuff before. So if I divided this side by 3, what?
3.
I got to divide that side by 3. Okay? This is where the cancellation takes place. 3 over 3. We learned that before. Remember we had that division thing where we had the same thing over itself? What does that equal to? What's anything divided by itself? It's 1, isn't it? So we say we cancel out, but why does the 3 and the 3 cancel out? Right, because the 3 divided by 3 is 1. What's 1 times x? It's just x. You understand that? A lot of teachers just say cancel right off the bat, and they don't really explain why they cancel out. This is why they cancel out. Because 3 divided by 3 is 1. 1 times x is just x. And we don't need that 1 there. And now we can go x equals what? 5. All right, so that's how you would do a problem like that. That's cancellation. All right, that's not too hard, is it? What if we had stuff that was kind of, remember this stuff I crossed out right here? This would be cancellation. Now, it's an extra step because you got negative exponents and stuff and you got exponents, but we'll get to that some other time. But this is still cancellation. Watch, what if I go AC over BC? What if I wanted to simplify this? That's what they would tell you here. On this one, they would say solve. On this one, they would say simplify. So what can you do here? I got AC over BC. Go ahead, Carter. Yeah, what she said. That's all right. So you can cancel out the C's because anytime you have something over itself, it just becomes a 1, doesn't it? Anything divided by self is a 1, so that we say cancels out. But really, it divides out to be a 1. That's what technically is happening. And what are you left with here? Just A over B. Now, of course, this A, B, and C stuff represent numbers, right? So there you go. Well, we didn't finish, so we're not going to give homework tonight. I'll finish the lesson tomorrow, then I'll give you homework tomorrow. Okay? Everybody good? All right.